What I want to do is review writing polynomials with complex roots, and it's part of the bonus problem I gave to today's assignment. There's a couple key things in this video you really want to study because I'm adding a little extra information. On the district exam, they're not going to give you all the zeros that they want, and you're going to have to find the extra zeros. So let's go to the screen here. And I want you to take a hard look when it says write a polynomial in expanded form with the roots x equals 3 and x equals 2i. And then it says with real coefficients. Now, this little part right here with real coefficients tells us a lot about what they want. And they're looking for a standard polynomial, things like 2x. Let me get rid of all that. Sorry. Let me edit the features here. They're looking for things like 2x squared plus 3x plus 5. Let's just say like that would be a polynomial with real number coefficients. All right? They're not looking for things like this. F of x equals I x squared plus 2ix minus 7. They don't want to see I in the final answer. And since they're not looking for this kind of crazy polynomial, they're looking for the ones with real coefficients. What that means is something very powerful in order to get a final answer like this. It means a complex roots come in pairs for polynomials with real coefficients. So if a problem says x equals 4i is a 0, you can assume x equals negative 4i is the other 0. All right? And then it even gets more complicated, but not too hard to follow, but you can follow it. They'll sometimes say something at the highest levels. Complex roots can have the form a plus or minus bi. If a problem says x equals 1 minus 2i is a 0, you can assume x equals 1 plus 2i is the other 0. Now, I'm not going to go through this particular case today because I feel that if you can handle this one, you really moved up the chart and you're really proficient. You really have an understanding. So let's look at this information. It says write a polynomial in expanded form. Okay, write a polynomial in expanded form. How do we do that? Oh, you have to remember, oh yeah, Mr. Polsing taught me. I've got to make a table where the first column is the zeros, the next column is the equations, and the last columns are the factors. And then when you look at this, you see 2 zeros, so you think to yourself, you have 2 zeros. But it says with real coefficients, so the trick is that rule here. If there's a plus, you need the minus. Well, they gave us the plus 2i, okay? Well, the first they gave us x equals 3. Then they give us x equals 2i. And then you have to say, aha, if I need real coefficients, I need a third 0. You need x equals minus 2i. So this is very important. In the problems I give you in class, I've given you the plus 2i and the minus 2i, so it always works out nice. But on the district final, they're not going to do that. They're going to say they're only going to give you one of them, and you have to come up with the other. So you've already learned my strategies about x minus 3 equaling 0, and you've learned x minus 2i equals 0, and you've learned x plus 2i equals 0. There's nothing new here. You're just moving the number to the other side and changing signs, and you're getting the factors x minus 3, x minus 2i, and x plus 2i. Now the trick is when you do the multiplication. I'm going to try to show you the simplest way to multiply this all together. The first thing you do is when you write the function in factored form, you say, okay, I need this function. So you say, okay, f of x equals, you pick the complex roots to be multiplied first. So you write down x minus 2i times x plus 2i times x minus 3. Now, the reason you want to do that is whether or not you realize that this is a difference of squares. Okay, I've taught you to do FOIL, and you can do FOIL, and I will do FOIL. But there's a really fast way to multiply this. But for now, we'll practice our first, our inner, our outer, our last. And if you do this, you'll end up with the x squared. You'll end up with a minus 2ix. You'll end up with a plus 2ix. And now the last one you have to be careful of. You'll end up with a minus 2 times a positive 2, which is a minus 4. Look at that last one. Okay, let me highlight that last one because this is really important. You're going to end up with that minus 2i times that plus 2i. That last part will create for you the minus 4, and then you get an I times I, which is an I squared. It's very important. All right? And then here, you still have the x minus 3. Now, when you get really good at this, you're going to figure out that this part in the middle goes away, and that's the magic about multiplying by the positive and negative complex roots, or actually they're called conjugate pairs, where the plus I part and the minus I part knocks itself out. And then you have to remember the key fact, and there's a key fact you always have to remember. I squared always equals -1. This is an extremely important fact because that's what makes it into the real numbers. So this I squared you can write down as x squared. You have that minus sign, so you put the minus, but the I squared becomes a -1. And you still are multiplying by x minus 3. Okay? Now I'm going to extend the paper a little bit here. And so, just remember you're going step by step all the way down. Now this minus on the -1 ends up being x squared plus 1 times x minus 3. And you know you're not finished because you still have multiplication between two binomials. And you do FOIL again. But in this particular case, even though you're doing your first and you're still doing the inner and you're doing the outer and you're doing the last, the powers are different. So you have to kind of be a tiny bit careful, but it shouldn't be too hard. So you do the first x squared times x, you write down x cubed. You do the inner 1 times x, so you write down plus 1x. You do the outer, you do x squared times minus 3, you get a minus 3x squared. And you do the last 1 times -3, and you get a -3. Now, this is not in standard form. This is an expanded form. And the reason is because the powers are out of order. You want the powers in order. So our final answer is x cubed minus 3x squared plus x minus 3. And this is a polynomial in standard form that has the zeros x equals 3, x equals 2i, and needs the x equals -2i added in order. Sorry, here, let me get this part down. In order that these coefficients are all real numbers. And there it is. I hope that helps out. Keep hitting the rewind button if you need to go over it again, but it should help you with the bonus. Thanks for watching.